This question demonstrates a typical kind of precipitation question you might encounter. It asks, does a reaction occur when an aqueous solution of zinc 2 chloride is mixed with a solution of sodium sulfide? And then it goes on to say, if so, what is the net ionic equation? Well, the first thing is we have to figure out what the formulas are of the two reactants. So, in this case, we also then have to identify whether these compounds are soluble or not in water. So, for the first step here, we have to recognize that chloride is a -1 ion and zinc is a 2 plus ion. So, we do the crisscross and we find that the formula for zinc 2 chloride is ZnCl2. For sodium sulfide, sulfide is a 2 minus ion and sodium is a +1 ion. And therefore, if we do the crisscross, we're going to need a formula of Na2S. In this case, the zinc chloride would be soluble because most chlorides are soluble, and zinc is not an exception to that rule. Likewise, sodium sulfide would be expected to be soluble because sodium is a group 1 ion, and all group 1 ion compounds are going to be soluble in aqueous solution. So therefore, we are going to use that to start writing our chemical reaction. And so, since both of those compounds are soluble, we put an AQ after the formula to indicate that these are solutions. The first step in trying to determine the net ionic equation will be determining the products that could be formed by combining these two solutions. So we need to switch the ions. In this case, if we combine the zinc 2 plus ion with the sulfide 2 minus ion, we would come up with a formula of ZnS. The other product of this reaction would come from combining the sodium ion with the chloride ion, which would produce a formula of NaCl. At this stage, then, we need to recognize that these reactions, precipitation reactions, also fall into a broad category referred to as an exchange reaction, or sometimes referred to as a double replacement reaction. At this stage, we have to decide whether or not the products will be soluble or insoluble in aqueous solutions, so we need to consult the solubility rules. In this particular case, the rules for sulfides indicate that they are usually insoluble, and zinc is not an exception to that rule. So, in fact, then the zinc sulfide will form a precipitate. And so we put an S after in parentheses after the formula. Likewise, for the sodium chloride, we look at the solubility rules and we recognize that sodium is a group 1 ion. All group 1 ion containing compounds are soluble, so we would expect this to be a soluble compound. Likewise, most chloride compounds are soluble, and of course sodium is not an exception to that. So what we will do is put an AQ after the formula for sodium chloride. Since one of our products is insoluble in solution, this is readily recognized then as a precipitation reaction. And so we need to then do a little bit more work, and therefore we have to balance this chemical reaction. To do this, we can start out by recognizing that the sodium ions, we have 2 sodiums on the left side. To put a 2 in front of the sodium chloride balances the sodiums, but it also then balances the chloride. So that is a fairly simple way to go about balancing this reaction. This is then the so-called molecular equation. Once we have the molecular equation, then we need to write the complete ionic reaction by breaking apart any of the electrolytes into their component ions. An easy way to recognize the compounds that will be broken apart or dissociated will be anything that has a Q in the parentheses after the formula. The solid is not going to be dissolved in the solution, and so therefore that will remain exactly the same in terms of formula as you see it here. So we dissociate all of the ions, keeping track of the stoichiometric coefficients that are necessary. So for example, zinc chloride has 2 chlorides. We would need 2 chlorides in the complete ionic reaction. Likewise, sodium sulfide has 2 sodium ions, so we would need 2 sodium ions as the reactants. So this reaction then is balanced, so we see that we have the same number of atoms on both sides of this reaction. This is the balanced complete ionic equation, and you'll notice that any compound that is considered a salt and has a parentheses at AQ after it will meet the definition of what we call a strong electrolyte, and therefore will be broken apart into ions. At this stage, we need to determine what the spectator ions are in this overall reaction, and so in this particular case, chloride appears with the same number of ions on both the reactant and product side, and likewise the sodium ions appear on both sides of the arrow. So those are our 2 spectator ions in this reaction. If we rewrite the reaction and leave out the spectator ions, we then have our net ionic equation. As a final example, in this question, we're going to write the molecular complete ionic and net ionic equations for the reaction of silver 1 nitrate with ammonium carbonate. So again, the first thing we're going to do is try to write the molecular formulas for both the reactants and then the possible products. So silver nitrate, silver is +1, nitrate is -1. So you get the formula of AgNO3. The other reactant is ammonium carbonate. Ammonium ion is +1, carbonate is 2-, so we need 2 of the ammonium ions. Since ammonium is a polyatomic ion, make sure to put that in parentheses. And then if we switch the ions and combine the silver with the carbonate, the silver being +1 and the carbonate is -2, that then requires that we do the crisscross and we get Ag2CO3. The other product is ammonium nitrate. Ammonium ion is +1 and nitrate's -1. So hence we get the formula you see here. At this stage, we need to make sure we know which species are soluble. Silver nitrates are always soluble, so that will be AQ then. Ammonium carbonate, all ammonium compounds are soluble, so we would put an AQ after that. Silver carbonate, most carbonates are insoluble, but it turns out that then silver is not an exception to that statement. So there's our precipitate. And then finally the other product, ammonium nitrate. Ammonium compounds are always soluble. Nitrate compounds are always soluble. So this is AQ. At this stage, we need to take anything that is got AQ after the formula and break it apart into ions to get the complete ionic equation. And before we do that, we should make sure that we have balanced the chemical reaction. And then we can write our ions. In this case here are all the reactant ions, and then on the product side, the precipitate, which is the solid, is not broken apart into the ions, so we write that exactly as we had it in the molecular equation. But the ammonium nitrate is an electrolyte, therefore we write the corresponding ions with the coefficients in front of the formulas. And so at this stage, we can look for what is the spectator, or what are the spectator ions. Turns out both ammonium and nitrate are spectator species. and therefore we can cancel them out of the reaction, leaving behind the species that will appear in the net ionic equation. And so 2 silver ions plus carbonate will produce silver carbonate as a precipitate.